You've seen how to add, subtract, and multiply polynomials. Like the integers, polynomials are closed under addition, subtraction, and multiplication. This means that the sum, difference, or product of polynomials is another polynomial. Now comes division of polynomials. As before, we'll study the properties of integers and see how they apply to polynomials. When you divide an integer by another integer, several things can happen. First, if you divide by 0, the quotient is undefined. Second, if you divide integers where the dividend is a multiple of the divisor, then the quotient is an integer. Third, if you divide integers where the dividend is not a multiple of the divisor, then the quotient is not an integer. Because of these three different cases, integers are not closed under division. The same applies to polynomials. When you divide a polynomial by another polynomial, several different things can happen. First, if you divide by 0, the quotient is undefined. Second, if you divide polynomials where the dividend is a multiple of the divisor, then the quotient is a polynomial. Third, if you divide polynomials where the dividend is not a multiple of the divisor, then the quotient is not a polynomial. Because of these three different cases, polynomials are not closed under division. The rest of this video is devoted to the second case, where the quotient is a polynomial. In other words, cases where it is possible to divide one polynomial by another. Let's first look at what it means for one number to be divisible by another. The reason that 24 is divisible by 6 is because both numbers have common factors. When we write each number as the product of prime factors, you can easily divide out common factors. This is what division means operationally. Find and divide out common factors. The same idea applies to polynomials. One helpful way of dividing polynomials is to find common factors. Let's start with a simple example: factoring out a monomial from both the numerator and denominator. In this example, we're dividing the binomial expression 8x squared minus 6x by 2x. You can factor out a 2x from the numerator and denominator, as shown. The next step shows the 2x completely factored out of the numerator, making it easier to divide out this monomial from both the top and bottom, leaving 4x minus 3 as the quotient. And as you can see, this quotient is a polynomial. When dividing polynomials, look for opportunities to factor out monomials. With other polynomials, look for opportunities to factor out a binomial from the top and bottom. For example, here is a quadratic trinomial divided by a linear binomial. Although we have a separate video on factoring polynomials, here we'll show you that the quadratic term is equivalent to the binomial x plus 1 squared. Here you can see that the binomial x plus 1 is common to both numerator and denominator and can be factored out, as shown. This leaves the binomial x plus 1 as the quotient. There are two techniques you can use to divide polynomials. The first should look familiar and is called polynomial long division. In this example, we divide the quadratic trinomial by a linear binomial. The first step in the division is shown, followed by the second step. As a result, the original quadratic trinomial can be rewritten as the product of two factors, each a linear binomial. Since polynomial division is not closed under division, not all polynomials can be factored this way. Another technique, called synthetic division, is a way of testing if a linear binomial is a factor of a higher degree polynomial. For example, is x minus 2 a factor of x squared minus 6x plus 8? With synthetic division, we take these values and align them as shown. We drop the leading coefficient as shown. Then we multiply this value by the potential root, as shown. We add the two values, as shown. Once again, multiply by the potential root. If the final sum is 0, then the original binomial is a root. As a result, we can show that the original quadratic trinomial is the product of two linear binomials. Now let's look at some examples. The area of this rectangle is expressed by this quadratic trinomial. The width of the rectangle is expressed by a linear binomial. What is the length of the rectangle? To find the length, divide the area by the width, which results in this polynomial division expression. We'll use polynomial long division. The division shows that the expression for the area is divisible by x plus 3. So the length of the rectangle is x plus 5. Let's look at another example. The shape of this roller coaster is based on this polynomial. Notice how the graph intersects the x-axis at x equals 1. Does that mean that x minus 1 is a factor of the cubic polynomial? The synthetic division shows that x minus 1 is a factor. As a result, the cubic can be rewritten as the product of a linear binomial and a quadratic trinomial. See if you can divide this quadratic further. As a final hint, take a look at the other intersections the graph has with the x-axis.